to be able to prepare you for those things that you'd see in college. So these are college prep type questions, and they're multiple choice. So the worst thing you could do is just not pick anything. But why don't you work with the person next to you, group of 2 or 3, and see if you can come up with what you think is right. Go ahead, take a shot. Go. All right, let's see what you got. The first one, 4x cubed times 3xy squared times 2xy squared. 4 times 3 times 2 is 24. X to the third, x to the first, and x to the first makes x to the fifth. And then y squared and y squared makes y to the fourth. So the answer is letter J. You add the exponents when you're multiplying. If you're taking a power to a power, you multiply. You get n to the 77th. And in this situation, it says that if n to the x over n to the y is equal to n squared, which of the following must be true? Looks complicated, but for example, if you had n to the 9th over n to the 7th, that would be n squared. Because if you subtract the two exponents, you get 2. So x minus y is equal to 2. It's letter G. Okay? And that's that. So you can see that my printer for the smartboard doesn't always get everything. But what we're learning today is if you have two bases that are the same, you add the exponents. This would be a to the x plus y. So if I can give you an example, if you have, say, x to the 4th times x to the 9th, that's x to the 13th. X to the 13th. So that's a review from your properties. You would have focused a lot on that back in your intermediate algebra class as well as your algebra 2 class. Suppose you have a base with an exponent and it's taken to a power. A to the mn, that would be the same as a to the m times n. So for example, if you have x to the 3rd and you're going to raise that to the 4th power, that would be x to the 12th power. That's that example. And if you have a to the s and a to the r and you're dividing them, that's equal to a to the s minus r. You subtract those. Or in other words, if you had x to the 5th over x squared, you get an x to the 3rd. So what we have is our opportunity to review exponents. If you notice from our last test that we had, everything was x to the 1st power. You don't have mine?
I can dig it out.
Oh, no, just whenever you're ready. Just want you to know you're welcome. So, last test, everything was x to the 1st power. In this unit, x is not always going to be the 1st power. We need to learn how to deal with higher degree polynomials. They're much more interesting. They don't always make line shapes. They make other shapes, curves, and things of that nature. So we call these terms monomials because they simply have just a constant, a variable, and an exponent. And when you multiply two monomials together, all we have to do is just multiply the coefficients to get 15. And then what do we do to the exponents? And you get x to the 7th. So that'll be the first thing you'll be asked to do on the test. Why don't you try number 2 on your own? Go. And you should have 18 and then x and y. It's going to be x to what power? Thank you. I promise. X to what power? 8 and y to the 7th. We'll skip number 3 and go straight to number 4. Here we have 3 monomials. We don't distribute from multiplication to multiplication. Distribution happens over subtraction and addition. We'll talk about that later. But here you just multiply the 5, the 2, and the 3. We get 30. Notice that this s does not have an exponent on it. What is the exponent if it's not listed? It is 1. So s to the 1, s to the 5th makes s to the 6th, and then s to the 6th makes s to the 12th. t, we have 3, 2, and 1. That makes 6. And u, we have 4 and 3 makes 7. 7 plus 2 is 9. Not too bad, right? How is 5 different? Right, and you have 2 monomials that you're multiplying. They are separated by subtraction. So in this situation, you can make one monomial in the end. That is one monomial. Okay, that's what monomial means, is a single term. This one is a binomial. It's separated by subtraction. So you're going to end up with 2 parts, a binomial in the end. We distribute this here, and we distribute this here. And notice how we get 4 times 3 is 12, x to the 7th, subtraction, 24, x to the 6th. Go ahead and try number 6 on your own. As you distribute number 6, we should get a 6x to the 3rd, y to the 12th, minus 12x squared, y to the 9th. Okay. We all okay there? So that's multiplying. In this situation, this is where people start to get confused. I'm going to rewrite these first 2 so you can understand a backup plan that you always have. So sometimes people get to the test and are like, Mr. Gantz, I can't remember what I do when. Well, x to the 3rd to the 4th power, what that truly means is x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. That's what that means. Now, you don't have to write it out every time, but some people do. Notice now it's just like a problem we just did, right? In this situation, what do you do to the exponents? You add them. 3 plus 3 plus 3 plus 3 is 12. If you didn't want to write it out like that, you can look at it as a power to a power, and in there you multiply. See the 2 different ways of expressing it? That's up to you in terms of how you want to handle it. In this one, I could also write it as 2x squared y to the 5th times 2x squared y to the 5th times 2x squared y to the 5th. Now, people often wonder, well, do you take this 2 out front, this coefficient, do you multiply it by 3? No, I don't multiply it by 3. I take 2 times 2 times 2. I take 2 to the 3rd power, which is 8. And then you have x squared times x squared times x squared, which is x to the 6th. And then y to the 5th times y to the 5th times y to the 5th, which is y to the 15th. JC, question? Sure? All right. So for number 9, I'm not going to write 9 out. I'm going to take this negative 3 and I'm going to raise it to the 4th power. Negative 3 times negative 3. 9 times negative 3. Negative 27 times negative 3. 81. The rest are easy. A cubed to the 4th power. Do I add or do I multiply? Multiply. I get a to the 12th. B to the 4th and C to the 20th. Good. Try number 10 on your own. Go. If anybody sees my remote in class, 2 people who shall not be named during this hour because they are evil, they stole my remote, but they said that it's somewhere in my room that can be seen right now. They say you can see it. If anybody sees my remote, let me know. Because I'm trying to act like it doesn't bother me that I don't have the remote, but deep down inside it is kind of irking me a little bit. But that's what they want. They want it to irk me, and I don't want to let them know that they're getting to me. So, yeah, I will. Thank you. Thank you. Yes, new TV show. Anybody watch? Have you seen the advertisement for it? Poker Face. It's on. I think it's on Paramount, something like that. It looks good. All right, I've got 16, C to the 6th, D to the 4th, E to the 8th. We all good there? Okay, let's try two that are a little bit more challenging. What makes 11 different from the other two? Yeah, there's two different monomials. I'm taking one to a third power and one to the second power. And after that, I multiply them together. So I'm going to write two different monomials here that I'll multiply. The first one will be x to the 15th and then y to the 6th. The second one will be x to the 6th, y to the 8th. So, and now, as I multiply them, I add the exponents. So what I like about this question is you have to do two parts. You have to take the power to a power, which is multiply, and as you multiply, you need to add your exponents. So x to the 21st, y to the 14th. You try number 12 on your own. I kind of have a messy room, so. Yeah. I do feel I brought this upon myself. Right. All right, I cube that and I square that. I get 8x to the 12th. I get 9x to the 10th. Then I multiply. You should have a 72x to the 22nd power. We're on the same page? Okay, let's try then the part that's just a little bit more challenging, and that's dividing. Okay? And sometimes it's more challenging for people because we get to negative exponents. They're wondering, what do we do about negative exponent? So we'll show you. If you're dividing, you simply subtract the exponents. So x to the 6th over x to the 4th will give me x to the 2nd. For example 2, notice you have a 10 and a 5 out front. You don't subtract those, you divide them. And 10 divided by 5 is 2. And then we have 3 minus 2 is 1, so you get x to the 1st. And then 3 minus 7 is negative 4. Now, one rule that we have in mathematics is never leave a negative exponent. Never express something as a negative exponent. So as you have this negative 4, we're going to write it as 2x over y to the 4th. So please always drop your negative exponents to the denominator. Or if you have a negative exponent in the denominator, move it to the numerator. Move it on up. So here, 8 and 12 don't divide evenly, but we can simplify those. 8 and 12 are both divisible by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. Now I look at my x's, okay? X to the 3rd and x to the 9th. Sometimes how I like to think about instead of subtracting is how many are going to cancel? I have 3 on the top, I have 9 in the bottom. So 3 of them will cancel, leaving me with how many? 6. Will it be x to the 6th in the top, or will it be x to the 6th in the bottom? X to the 6th in the bottom because there's more in the bottom, right? There's more in the denominator, so that's where it's going to stay. Whereas the next one, y to the 7th over y squared is going to leave me with y to the 5th, and that is going to be in the numerator because there are more in the top. Okay? And that's simplified. Example 4, what makes that different? I got that negative exponent. You can just take a negative exponent if you see it, and you can move it to where it's not. So this becomes x to the third times x to the sixth. You can move it up to the numerator. And so I get x to the ninth. Notice if you were to do that using subtraction, you would get the same thing. It would be x to the 3 minus negative 6. If you subtract the exponents, notice how you still get x to the ninth. So there's multiple ways of looking at it. But when you get these negative exponents, I think the best thing to do is to just move them right away. So a lot of people's approach happens to be like this. First of all, they take 3 divided by 9 and they get 1/3. And then they write the x squared, the x to the negative third. That's going to move to the bottom and become x to the positive 3. I'll cross them off as I kind of encounter them. I've already done the 3/9. I've done the x squared. I've done the x to the negative third. The y to the negative fifth, that's going to what? Move up top, y to the fifth. And the y to the negative fourth is going to move to the bottom. So one strategy that people like to use is to move all the negative exponents first. Well, I've done that. If we deal with our y's, y to the fifth over y to the fourth is going to become just y to the first in the top. In the bottom, I have 3, and then x squared times x to the third is x to the fifth. So when you get negative exponents, move them. Let's try number 6. That looks a little tricky. This asks me to square them. We'll start by squaring this. What is 3 squared? 9. And then it's going to be x to what power? Negative 2 to the second. So that's, I'm going to, if I have a power to a power, I multiply. And negative 2 times 2 is negative 4. In the bottom, I have 2 to the third, and 2 to the third is, that's 2 times 2 times 2. 8. X to the negative 15. Now, I don't want to have these negative exponents, so I can move the x to the negative fourth down here, and I can move the x to the negative 15th up here. And I get 9x to the 15th over 8x to the 4th. Notice how the 9 and the 8 don't move. Those don't have a negative exponent. Just the x's move. And now x to the 15th over x to the 4th, that's nice and easy. That's x to the 11th. Whoop, sorry, over 8. I don't want to look at example 7 and 8 today. I'd like to look at those tomorrow. But your homework assignment is pretty short. If you flip to it, it's just a variety of problems involving exponents, and it's just the front sheet. You should be able to work on that for the remainder of the hour, and my guess is you should be able to get it done and be able to check your answers. I will post them up on the board here in just a second.